All right, good morning, class. Welcome back to another screencast lesson here. Today I thought we would revisit quadratic inequalities. You guys were assigned to watch that Ed puzzle video yesterday, and there was a worksheet to go along with it, but I know there was a little bit of confusion on that, part of which I created because initially the answer key was set up to match similar but not the exact same problems as to what was on there. So that should have since been corrected, but let's review that idea anyway. So when we talk inequalities, we started out looking at more basic inequalities, something like 2x minus 8 is greater than 2. And if we want to simplify and solve for x, we would add 8 to each side. Let's see, 2x is greater than 10, and then divide by 2 so that x was greater than 5. We could then represent that answer on a number line, knowing where 0 was and out here where 5 is. It says x is greater than 5. It can't be equal to, so I have to have an open circle. And then, really, I know the numbers bigger than 5 are to the right, but to be safe, I could test. I'll plug in 0 for x. 0 is not greater than 5. That doesn't work. So that's how I know for sure not to shade to the left side of 5. So that's just a quick review of inequalities that we'd seen basically. We even moved to those in two variables, x and y. Today we're going back to one variable. However, we're going to look at quadratic, or something with x squared in the inequality. So let's go back, let's clear some space, and let's take a look at one of those. So an example of a quadratic inequality might be something like x squared plus 8x plus 12 is greater than or equal to 0. Let's start with just that. So just like in the previous inequality, we want to simplify by getting x all alone on one side. We can't use inverse operations to solve this one if you remember working with quadratics. So instead, to get the boundary point that we want, or in this case boundary points, we'll have to do something like factoring or completing the square or the quadratic formula. Factoring should always be our first stop, so let's try that and see if it works. So if I set up my rectangle to help me factor in my diamond problem, I know that x squared and 12 will be in the corners, and their product will match the product of the other two diagonal boxes. So 12x squared will go on the top. We have a total of 8x's. So we look what multiplies to 12x squared and adds to 8x. Those numbers are 6x and 2x. So I can fill those in. And now I can pull out those factors. So x is coming out there. 12 and 6 have a 6 in common. 2 and 12 have a 2 in common. So now I know my factors are x plus 2 multiplied by x plus 6. And those are still greater than or equal to 0. You may have noticed in the video yesterday, they didn't rely on that structure of the rectangle and diamond problem. They simply looked for what would multiply to 12 and also add to 8, and that's what they added with x. And that is okay as long as we don't have any kind of leading coefficient in front of x squared. So that's a nice shortcut for factoring that you are welcome to start thinking about. All right, now that we have those, we can still rely on the zero product property to tell us the values of x that would make this equal to 0. And remember, those are our boundary points. Even though it's an inequality, we solve it like an equation to get the boundary points on our number line. So x plus 2, I'm just going to write equals. X plus 2 is equal to 0, and also x plus 6 is equal to 0. That means that x is equal to negative 2, and x is equal to negative 6. All right. Good news is we have our boundary points, so we can be thinking about our number line. On our number line, if 0 is right here, we'll be at negative 2 and negative 6. Those are our boundary points. And I right away can be thinking, okay, it said greater than or equal to. And since it's equal to, I know I'll have closed circles on each of those. The tricky thing here is there are actually 3 places our answers could lie that would make this inequality true. They could be the values less than -6. They could be the values between -6 and -2. Or the values that are greater than -2. So we need to test this out by picking a few test points to see, because we don't want to just rely on what the inequality sign told us. So if we go back and we test things out a little bit, we can go all the way back to our original inequality, actually. Let's clear some space to do that. So -6, well, let's pick something. -10's a good one. Really, any number you're comfortable working with could be fine. Let's do -10. So -10 all squared plus 8 multiplied by -10 plus 12 has to be greater than or equal to 0. When we do that, we get 100 plus -80 plus 12 is greater than or equal to 0. And I think you can probably see already that's going to be true. Simplifying it, we get that 32 is greater than or equal to 0. And what that means is that all the values that are less than -6, because -10 is less than -6, they make that true. So we'll be shading to the left of -6 on our number line. Those are the values that are making this true. We're not done yet, because there still could be other options. We could be in between -6 and -2, or also greater than -2 as well. So we should continue testing 2 more values. So if we go back now and pick something in between -6 and -2, let's try -3. So -3 squared plus 8 multiplied by -3 plus 12 is greater than or equal to 0. Well, that means that 9 plus -24 plus 12 would be greater than or equal to 0. Oh, that -24 is pretty big. When we combine everything there, we end up seeing that -3 is greater than or equal to 0. That is not true, so we can't shade in between those values. All right, last check, we have to pick something greater than -2, and this one's really nice because we can pick 0. So if I put in 0, 0 squared plus 8 times 0, you wouldn't even have to write this down necessarily. Right away those cancel out. We see 12 is greater than or equal to 0. That is true. So the values also work going to the right where we're greater than -2. It's really important we test those 3 areas, because in this case you'll see it wasn't enough to just stop when we got one that worked. We have 2 separate sets of numbers that work because we're squaring. So there are certain negative values that work and there are certain positive values that work here. Typically, you'll see the values in between work, or it's the other 2 possible solution areas that work, like we've seen here. One thing that was shown in yesterday's video, which we haven't talked a whole lot, is an alternative way to represent those solutions. So we can show them on the number line. We could even write x is less than or equal to -6, and x is greater than or equal to -2. That is correct. But there's also another notation we can use using either brackets or parentheses. So when we have values for x that go on forever in the negative direction, that means they're going all the way to -infinity. That's the leftmost boundary, the least we can get for the value of x. We can't ever equal -infinity, but we're going to go in that direction. So we can put that in one side of our little group here, and then the other side stops at -6, and it can equal -6 because we used a closed circle. We said it was less than or equal to. And the reason I say it can equal it is because that means instead of a parenthesis, we put a bracket there. So to represent the values here, we can use this notation. Over on the right side, well, we see that we can be equal to -2 and go all the way in the positive direction to infinity. You can't really be equal to infinity, so we use a parenthesis there because it's not equal. So that's a new notation, and we would put both of those together to represent all of the solutions that work. Nothing new mathematically, just a new way to write our solution. So right now we've got 3 different representations of your solutions here. All right, let's look at one more of these quadratic inequalities just to get a little bit more practice. So if we go to the next page, we'll do the same thing. We know that it'll be an inequality that has x squared in it. Let's look at x squared plus 7x plus 7 and say that is less than or equal to -5. So with this inequality, you may have noticed it's slightly different than the other because the other one had 0 by itself already. This isn't an inequality issue so much as a quadratics issue. Remember, we've always needed to get the quadratic equal to 0 before we were able to proceed completing the square or factoring or the quadratic formula. And this is no different. So our first step is to treat this like an equation to get the boundary points, which means let's solve using inverse operations. So if we add 5, we get x squared plus 7x plus 12 is less than or equal to 0. And right away we've turned it into something we can work with. Our first stop is factoring. Let's see if that works. So we have x squared and 12 in our corners, 12x squared. This time we're adding to 7x, so it's a similar problem to the previous one. We have 12x on the top. Factors of 12 that add to 7 are 3 and 4, and we need the x there. So those will go in the corners. When we take out our factors, you'll see you get the x's, and then we'll pull out a 3, and we'll pull out a 4. And this is where, again, that little bit of a factoring shortcut could have been used, because we get x plus 4 and x plus 3. You could see that 3 and 4 add to 7, multiply to 12 right away. So that's a shortcut you can be considering. This is still less than or equal to 0. Now we use the 0 product property, and we know that x plus 4 is equal to 0, or x plus 3 is equal to 0, meaning our values are x is equal to -4 or x is equal to -3. Same process we used previously. The last step is to get on that number line this time. I still like to know where 0 is, but we're going to be over at -3. And then right next to it at -4. Now, you know what, let's go by 2 so we have a little space there. So 1, 2, 3, 4, 5. So there's -3, then -4. All right, same idea. We know that we're looking at a less than or equal to situation, so I can put my shaded circles right away. Then we need to test those 3 boundary areas as well. So -4, well, let's go less than that first, so we're testing to the left of it. Doing that, well, that means -5 could be one we could use. So -5 squared plus 7 multiplied by -5 plus 12 is less than or equal to 0. Well, that means 25 plus -35 plus 12 is less than or equal to 0. When we add that together, we'll see that we get a positive value because we're looking at 37 plus -35, so 2 is less than or equal to 0. That's not true. So we aren't going to shade to the left. If we test again with a value this time, let's go to the right of -3. So let's test this area here. Well, that's the easy one where we get to put 0 in. Well, 0 squared plus 7 times 0 is all 0, so it ends up just saying 12 is less than or equal to 0. Again, not true. We don't shade to the right. What that means I almost know without a doubt it's between -4 and -3. If we want to confirm that, we'll have to use a decimal in this case, but we can work with that. So let's pick -3.5. So -3.5 squared plus 7 multiplied by 3.5 plus 12 is less than or equal to 0. If we pop over and use a calculator real quick, maybe. So we just need to quickly see, okay, -3.5 times -3.5, let's see what it is squared. It's 12.25. And then also we need 7 multiplied by -3.5, which is -24.5. So if we go back and fill those in, we had 12.25 plus -24.5 plus 12 is less than or equal to 0. When we add all that up, we end up seeing that -0.25 is less than or equal to 0, which is true, meaning we shade in between -4 and -3. Our other new way to write those answers now that we've done our work, well, we could say x is less than or equal to -3, x is greater than or equal to -4, or just put it in one nicely noted group here where we say -4 and then -3, because those are the values we're in between. Notice this time I used 2 brackets because -4 and -3 both can be values for x. So this was just a quick look at quadratic inequalities again. Hopefully this helps clear some things up. Please use these ideas to complete today's lesson, and let me know if you have any questions during office hours and we'll get those answered.